Today we'll be doing the integral from 0 to pi over 2 of sine of x times cosine of x divided by 1 plus cosine x dx. And we will start off by using something known as Weierstrass substitution. And it's essentially letting u equal the tangent of x over 2. And the sine of x transforms into 2u over 1 plus u squared. The cosine of x transforms into 1 minus u squared divided by 1 plus u squared, and dx will be 2 over 1 plus u squared du. And the bounds of integration, u1 will be 0 and u2 will be 1. So we're going to have the integral from 0 to 1 of 2u over 1 plus u squared, and then 1 minus u squared over 1 plus u squared divided by, we could write 1 as 1 plus u squared divided by 1 plus u squared plus 1 minus u squared divided by 1 plus u squared, and dx is 2 divided by 1 plus u squared du. These u squareds cancel, and this 1 plus 1 is 2, but this matches this 2, so this entire thing will end up canceling. So we have the integral from 0 to 1 of distributing these u's here. We have a 2u minus 2u cubed divided by 1 plus u squared du. And now we could split it. So we have twice the integral from 0 to 1 of u over 1 plus u squared minus 2 times the integral from 0 to 1 of u cubed divided by 1 plus u squared du. And we'll make a substitution on the first integral. So we're going to let v equal 1 plus u squared. But that means that dv over 2u is du. Bounds of integration, v1 is 1 and v2 is 2. So we have twice the integral from 1 to 2 of u over v squared times dv over 2u. And these u's end up canceling, and these 2's end up canceling. And we still have this secondary integral, so we have minus 2, the integral from 0 to 1, u cubed divided by 1 plus u squared du. And this integral will end up being minus 1 over v from 1 to 2, which is negative a half plus 1, which is equal to 1/2. So we're left with a 1/2 minus twice the integral from 0 to 1. We could rewrite u cubed as u squared times u divided by 1 plus u squared du. And we'll make one final substitution. We're going to let s equal 1 plus u squared. So that means that s1 will be 1 and s2 will be 2. And that means that s minus 1 equals u squared. And ds over 2u is du. So we have 1/2 minus twice the integral from 1 to 2. And then we're going to have s minus 1 times u divided by s squared and times ds over 2u. These 2's end up canceling. This u ends up canceling. So we have 1/2 minus the integral from 1 to 2. And we could split this into s over s squared minus 1 over s squared ds. So 1/2 minus the integral from 1 to 2 of 1 over s, and then minus 1 over s squared ds. We could distribute the negative. So we're left with 1/2 minus the integral from 1 to 2, 1 over s ds, plus the integral from 1 to 2 of 1 over s squared ds. So we're going to have a 1/2 minus the natural log of s from 1 to 2, and then we're going to have a minus 1 over s from 1 to 2. So now evaluating the bounds, we have 1/2 minus the natural log of 2 minus the natural log of 1 minus, we're going to have a 1/2 minus 1. And then we have 1/2, this cancels, minus the natural log of 2. And then we're going to have a negative 1/2 plus 1. And these 1/2s end up canceling, so we have 1 minus the natural log of 2. But I could rewrite 1 as the natural log of e, and minus the natural log of 2. And then using logarithm rules, combine them into a single log. So this is equal to the natural log of e over 2. And so that is the final result.